Hi everyone. Today I am going to discuss one of the important chapter, that is chemical bonding and molecular structure in your 11th grade. In that chapter, from your lower grade itself, you are studying about what is a water molecule, the formula H2O, ammonia, NH3. So how to determine the structure of that kind of molecules, that's very important. Because you are a chemistry student, it is compulsory to know how to find the structure of a molecule. So today we are discussing completely related with the structure determination. We have one of the theory how to find the structure, that is called it as VSEPR theory. The full form is valence shell electron pair repulsion theory. VSEPR theory corresponds to valence shell electron pair repulsion theory. According to the theory, so many postulates are there. So before coming to the postulate, let me discuss some common terms related with the chemical bonding chapter. They are, the first one, let's discuss about the term bond pair. Bond pair of electrons, and second one is lone pair of electron. Bond pair and lone pair of electron. What is the meaning of that? Bond pair means bond pair of electrons, which means those electrons which take part in bonding. Those electrons which take part in bonding is said to be bond pair. So what is lone pair? Those electron which does not take part in bonding. For example, if you consider one of the molecule ammonia, what is ammonia? NH3. In ammonia, nitrogen connected with a 3 hydrogen atom, and there is a representation like this. Here you can see that from nitrogen and hydrogen, they are sharing here 2 electrons. One single bond is equal to 2 electrons. So these 2 electrons are combining together and making nitrogen hydrogen a single bond. Similarly, this nitrogen and hydrogen making a single bond by using 2 electron, this also the same way. So these things, you can see these 2 electrons is a pair of electron which creating a bond. So these 2 electron which involved in bonding, therefore it is said to be a bond pair of electrons. So these 2 electron which making a single bond, so it's one bond pair. Then what is this? You can see 2 electrons are single occupying that without involving in bonding. That is said to be lone pair of electron. Those electron which does not taking part in bonding is said to be lone pair of electrons. So can you tell me how many bond pair and lone pair is present in this molecule? You can see that 1, 2, 3. There are 3 bond pair and only 1. See, 2 electron, 1 pair, right? 2 electron, 1 pair. Therefore, 2 electron, 1 bond pair, 2 electron, another 2 electron, third one. Here you can see 1 lone pair, 2 electron which does not take part in bonding. They are said to be lone pair. So 2 electrons are there, therefore 1 lone pair. So in this compound we can say there are 3 bond pair, 1 lone pair. So corresponding structures are there. You can see there is a ball on the screen. This is nothing but an atom. This is the central atom. The previous case we studied ammonia. Which was the central atom in ammonia? Nitrogen. Nitrogen is surrounded by so many hydrogen, right? Similarly, let us consider this is one of the central atom. Let me add some of the other elements on this one. Let me add one element here. One element is attacking and one more element. Now you can see here. Can you tell me, student, how many bond pair and lone pairs are present on this central atom? Student, you should find the bond pair and lone pair number on the central atom. Okay, not the surrounding element, on the central atom. Here you can see this is the central atom. It is connected with the 2 bonds, which mean 2 bond pair, right? You can see there are central atom surrounded by 2 atoms by 2 single bond, therefore 2 bond pair. 2 bond pair, and can you see any lone pair? Can you see any lone pair? No, right? All the electrons take part in bonding. So here we can say that this system having 2 bond pair, we can say there are 2 bond pair and 0 lone pair. There is 2 bond pair and 0 lone pair. For a system which contains 2 bond pair and 0 lone pair, it having the corresponding structure is said to be linear geometry. You can observe that. This is the central atom and this is the surrounding element. It is connected in a linear geometry, right? Linear geometry. So, all of you fix in your mind, if a system having 2 bond pair and 0 lone pair on your central atom, the structure is said to be linear geometry. Let me take the example BeCl2, beryllium dichloride. So, beryllium, here it is connected with the 2 chlorine atom, BeCl2. In which is the central atom? You know that the lesser in amount, which is the element beryllium. Here the beryllium is connected with the 2 chlorine atom, right? So beryllium is the central atom. Student, you studied in 10th grade how to write the Lewis structure of a molecule, Lewis symbol. You know that all the electrons in a molecule, in an atom, cannot take part in bonding. Only those electrons which are occurring in their valence shell. Only those electrons which are occur in the outermost shell can involve in bonding. Okay, right? So, you know beryllium, what is atomic number? Beryllium atomic number 4. Beryllium atomic number 4. So, you can write the configuration as 2, 2, right? 2, 2. K shell contain 2 electron, L shell contain 2 electron. So, can you tell me, student, what is the valence electron in beryllium? That's equal to 2. So, we can represent beryllium is connected with beryllium in the outermost shell, it having 2 electrons. You can represent by a dot or cross that you studied in 10th grade. And you can see the surrounding elements are which one? Chlorine, right? You can see 2 chlorines are there. You know, chlorine is a halogen. Chlorine is a halogen. So can you tell me how many valence electrons are present in chlorine? So let us discuss about that. You know, chlorine atomic number is 17. How can you write the configuration? 2, 8, 7. So you know what is the outermost electron? 7. So you can represent 7 electron on chlorine. 1, 2, 3, 4, 5, 6, 7. Similarly, this chlorine 1, 2, 3, 4, 5, 6, 7. So beryllium, once again I am repeating, while you are representing the chemical bonding, only represent the outermost electron on each atom. Beryllium outermost electron 2, chlorine outermost electron 7. Can you tell me, student, according to the chlorine atom, how many more electron required to complete its octet? You know, octet means outermost shell, 8 electron. Here you can see chlorine already completed 7 electron in their valence shell. It need 1 more. So what is possible? This chlorine can take a electron from beryllium. They will make a covalent bond by sharing. Similarly, this chlorine will take a element or electron from beryllium. Now you can observe which is your central atom? Beryllium. On the central atom beryllium, how many bond pair and lone pairs are there? You can see, student, beryllium connected with the 2 bond, which is equal to 2 bond pair. You cannot see any kind of lone pair on beryllium. So let's coming to the point. 2 bond pair and 0 lone pair, corresponding to the structure linear. So we can draw the geometry Be connected with a 2 chlorine atom in a linear geometry. This is the way how to find the structure of a molecule. Let's discuss one of the important geometry of the molecule. You have the central atom. Let's place the bond pairs. 1 bond pair, 2 bond pair, 3 bond pair, 4 bond pair, 5 bond pair. If you place 5 bond pair, by looking at the structure, it's difficult to understand what is the exact geometry of the molecule, right? Let's place in the proper order. This is the actual shape of this molecule. Actual shape of this molecule. It's very clear that if you observe this diagram, it's very clear that if I combine these 3 atoms, 1, 2, 3, if I connecting these 3 atoms, you're getting a trigonal planar geometry, right? Why it is called again planar? Because these three atoms and the central atom are lying on the same plane. So it's just like a trigonal planar, right? Now you can see one atom above the plane, one element below the plane. So the element which is lying above the plane, you can connect by this trigonal planar like this. If you connect this trigonal planar geometry with the upper element, now you are getting a pyramidal geometry. Can you see that? You are getting a pyramidal geometry. There is a trigonal planar, this is the base, and you can see there is a pyramidal geometry. Now you can observe one more element is occupying below the plane. Let's connect that one also. If you connect here and these three, now you can observe total there are around triagonal, one pyramidal above the plane, one pyramidal below the plane. This is called it as triagonal bipyramidal geometry. Triagonal bipyramidal, because there are two pyramidal, upper the plane and below the plane. Right. So let's place one of the example that is given to you, PCl5. PCl5, which is the central atom phosphorus. Phosphorus. What is the atomic number of phosphorus, student? That is equal to 15, right? 15. 15 means what is the configuration? Can we write it as 2, 8, 5. So what is the valence electron? 5. So let's place 5. 1, 2, 3, 4, 5 valence electron. It is surrounded by 5 chlorine atom. 1, 2, 3, 4, 5. Each chlorine valence electron, it is a halogen, so their valence electron will be 7. So each chlorine require 1 electron. It takes from phosphorus 1, 2, 3, 4, 5. Tell me, student, how many bond pair and lone pair in this geometry? Total there are 5 bond pair and 0 lone pair. Structure correspond to triagonal bipyramidal geometry. Let's draw the diagram. Phosphorus is the central atom. Let's break a triagonal planar first of all. 1 chlorine, 2nd chlorine, 3rd chlorine. Now you can make a triagonal planar. 1 of the chlorine above the plane, 1 of the chlorine below the plane. Now you can see triagonal, pyramidal, 1 pyramidal is said to be triagonal bipyramidal geometry. So in such a way, you can discuss or you can find the structure of any kind of molecule as per the VSEPR theory. Hope you get the idea. Thank you.